was not a nugget. Okay, so folks, now what I'd like to do is I would like to, we already simulated the model and we saw this. Okay, so we saw agent populations live in the main class. Environments can be used to position those objects and set them in networks. And now what we're going to actually do is we're going to work in a direction that will allow agents to be placed into a network. Okay. So first of all, we're going to tell the environment that we want to place individuals within a distance-based network, and we need to specify a threshold that by which we're going to have agents placed. So these agents are going to be located in space, as we've just seen, but we're going to set it so that they're also in a network connected with people closest to them. Okay, so in order to do that, we're going to click on the environment, and we are going to scroll down in the advanced properties of the environment to set the network type to be distance-based and the connection range to be 50, 50, okay? So that will be the environment. We scroll down under the advanced tab and we set this to be a distance-based network with a connection range of 50, okay? Mm-hmm. Okay, now once we've done that, these agents will be automatically placed into a network with nearby agents. If another agent lies within 50 time units, they will be logically connected with that agent, okay? But the problem is we can't see the network right now. So we want to be able to see this network. We want to be able to see to whom they're connected. So this is going to take a little bit of finesse. It's going to, again, push your limits, okay? And push your limits in a way that's going to disappear for any logic 7, fortunately, which is good. Okay, so what I'd like to do here is to double-click. First of all, we want to change the appearance of an agent so that agents not only are associated with ovals, they're associated with lines that connect them to other agents. So where would I go to do that? To where? Person. So if I want to make it so that persons are associated not just with ovals but with lines, where do I go to do that? Well, I have to go to person. Okay. Incidentally, you may notice, and you may wonder here, if you go to main, you'll also see this circle here? That shows the origin of where the agents will be placed in this space visually. This is the origin of sort of the agent space from this point here. That's what this denotes, this sort of circle here. That's why it's there, and if the agents were shaped differently, it would be a similar shape there. Let's double click on person, and what we need to do now is to add in a line to person, okay? This is going to be a line which starts in the center of this circle and which, excuse me, I added the wrong thing. We have to be very careful here. We're adding in, there's several things that look like a line in this palette. I added a transition. What I really want to add is a line from the presentation area, not a transition, okay? We want to drag a line over, and we want to make it so that the plus sign of the line is actually in the center of the oval. You'll notice the line is asymmetric. This is a dot, this is a plus. And we want the plus side of it to be in the middle of the oval. So let me rehearse that again. So I'm dragging from a line over here and setting it to be here. So the plus side is here and the dot is out here, okay? So now we're going to have agents associated with lines, so it should look something like this in close-up, okay? So who needs help from a TA? TA help? TAs deploy. TA help? Who else needs TA help? No help right now? Okay. Okay, folks, if you're unsuccessfully at initially placing it, you could just place it down and drag it, but the plus has to be there. Okay, so what will happen if we run this model? What will happen if we run this model, do you think? Yeah, it looks uninspiring. The agents' networks are not readily apparent. In fact, it looks like a set of pins. So what we need to do is to undergo a bit of finesse, and I'm going to show you an expansion and generalization of some of those things we saw this morning when we were dealing with visual properties. So ladies and gentlemen, when we needed to set the visual properties of that oval this morning, when we wanted to appear different colors based on sex, when we wanted it to appear different sizes based on income, where did we go to do that? Okay, to the oval, and once we were at the oval, what did we do? We were setting properties of an oval, so we went to the oval, and where did we look on that oval? Dynamic properties. So, ladies and gentlemen, we need to do the similar thing for this line. So let's click on this line. Who needs help here? Who needs TA help? They're eager to help, and with full bellies they could serve.
I still have half the blood going to my brain.
Kurt, watch out. Okay, so so we need to go to the line, and then we need to indicate dynamic here. Excuse me, I had put down this microphone. So we need to go to the dynamic properties associated with this line, and this line, okay, there's two problems with this line. We want this line to connect an agent with the other agents with which they're logically connected. We want to visually see this. So there's two things we have to do with this line. One is we need to make enough copies of line, one for each agent to whom this agent is connected. So if this agent is logically connected with 3 agents, there need to be 3 copies of this line. If this agent is connected with 2 other agents, there need to be 2 copies of this line. If this agent is connected with 10 other agents, we need indeed 10 copies of this line. So under the dynamic properties, you'll notice that there's a property, ladies and gentlemen, called replication here. Called replication. And I'd like you to set this replication to be equal to the number of connections this agent has. Yes? Okay. That is the question, indeed. So we, this is why I'm going over this, because this is a task you might need for other purposes as well. Maybe you want to report, for example, output to a spreadsheet how many connections a given agent has, and this would be a good thing to know how to do. So we need to ask the agent. We have to ask the agent, how many connections do you have? Now, to ask the agent, we have to address the agent. We have to say, okay, for me, how many connections do I have? We're setting this line to appear for a given agent. So we have to ask myself, okay, how many connections do I have? And to do that in Java, there's a special word called this. So I have to ask myself, hey, myself, get connections number. That's the number of connections. Returns the number of agents connected to this agent. Now, how would I have found that if I didn't know that? I'd look up in AnyLogic help, and I would then search for number of connections, and I could locate that. Okay, but that's what I have to put here for the replication. So what this is going to say is this line is going to be replicated that many times. So if I have 10 connections, there's going to be 10 lines. If I have 2 connections, there's going to be 2 lines. Why this dot? Do people remember where we saw a dot before? Where did we see a dot this morning? Besides at the end of your password.
You said it.
the state chart. State chart dot is state active. And so there we were asking the state chart, hey, state chart, tell me, do you have this active state, susceptible, is the state we're asking about. Here, we're asking ourselves, we're saying, hey, because we need to know for this agent, how many connections does it have? We have to ask that agent, hey, myself, how many connections do I have? And this is a Java expression, it computes a value, so I say for this, for myself, call my this get connections function or method it's called, and it will return a value, 3 or 10, okay? And that will replicate the number of lines. That's good. We're almost there. We have just one more thing to do. Okay, so we wanted a number of lines equal to the number of connections. That's what we have to do it. That's great. Okay, now we have to then go and, I have some comments on writing code here. Okay. Okay, now we have to connect the lines between each person. Now, the subtle thing here, folks, is that for a given line, each line from a given agent is going to go to a different neighbor, right? I might be connected with 3 neighbors, one on my left, upper left, one on my lower right, and one just to my right. And I want each line to go to the appropriate neighbor, right? True or not? Thank you, Wendy. So we want each line to go to the appropriate neighbor. And ladies and gentlemen, this is about as deep in the Java morass as I'm going to drag you this boot camp directly. Now, for your projects, you'll probably submerge yourself more fully, but in these particular lectures, this is about as far as it's going to go. So what I'd like you to do now is, again, in the properties of the line, because this is something about the line gets replicated this many times, and then for a given replicated line, we have to say how far does it go over in the x direction, and how far down does it go in the y direction, okay? Now if we scroll down here in the dynamic properties of line, there's replication up top, we scroll down, there's properties dx and dy. And you'll notice that these are actually what say how far over the line goes, how far down the line goes, okay? And you'll see next to it there's a little light bulb. And believe me, it will behoove you to check out light bulbs such as this, okay, in any logic, because it gives you hints. And the hint it gives here is you can use the word index in any expression put here. Index will mean the index of the replicated line. In other words, if you're dealing with the very first line, index will be 0. If you're dealing with the second line, the index will be 1. If you're doing the third line, it will be 2. In other words, it's the index of the replicated line of note. So if you have 3 connections, it'll be 0, 1, 2. Okay, so that's great. So now we need to figure out how far over this line goes. Well, how far over is it going to go? Well, if we're here, this is our index agent. And the agent we want to connect to is here. The agent we want to connect to is at xb, yb, and we're at xa, ya. The difference in x, the dx, is x sub b minus x sub a. Right? This guy's at x, the x coordinate is x sub b, and our x coordinate is x sub a. The line needs to go over to the right by xb minus xa. And similarly for y, it has to go down by yb minus yn. Sometimes those may be negative, that's fine. That's fine, it will just go in the opposite direction. Okay, so ladies and gentlemen, we're going to put together an expression here, and then I'll sort of explain better what's going on. I guess a few points here, maybe I'll say up front. Okay, so agents, I mentioned that agents are objects. They're things that are circulating while we're running the model, and we can have a reference to them. We can have sort of a thing that points to them, and the thing that points to me is called this. So if I'm an agent, I go around with a name. my name in reality is Nate, but I could also have a name this, and that kind of also refers to me, okay? And whatever person we're dealing with, they can use this to refer to themselves. And if we want to ask, okay, who's the agent connected with me? Like, who's the first agent connected with me? We would call that starting at 0. Who's the 0th agent connected with me? I can ask this.getConnectedAgent. And that will return a reference to that other agent I'm connected to, the very first one. I can call this.getConnectedAgent of 1 to get the second agent I'm connected to. I can call this.getConnectedAgent of 2 to get a reference to the third agent I'm connected to. Okay, so if I want to find out the connection, the location of this other agent, if I know that I'm dealing with line number 0, how could I get a reference to the connected agent for that line? Let's suppose I'm dealing with line number 0. Based on what I've just told you, how could I get a reference to the person to whom that line is connected? Okay, so there is a formula here. What would the formula be? If I want to get information on, if I want to get a reference to, some way of getting a reference to, so I can ask that agent, hey, what's your X location? How do I do that? Well, okay, so there is locations, but let's suppose they all have locations right now. We need to divide and conquer. They have locations right now. If we have a reference to a given agent, say for myself, I can call this.getX. That will return my X location, okay? I can call this.getY or return my Y location. That's given a reference. So in other words, I have a reference to myself called this, and I say, hey, what's my Y location? And this is what I call this.getY. This returns a value for my Y location. It's a double precision value, 32.3 in the Y location, and this.getX would return 10.25 or what have you. But I want to get a reference to this other agent to whom I'm connected. Yeah?
Get functions, and then we see get connected agent.
Okay, good. So the key thing, folks, here is that this is asking dx for a given line. There's replicated lines. Suppose there's 3 lines. Line 0, 1, 2 are the indexes of these lines. That's what this is telling us, that there's this index of the line given. It starts with 0, goes to 1 and 2 for each of the 3 lines in turn. So you'll notice there's this index it's going to give us. So index will tell us, is this line 0? Is this line 1? Is this line 2? And what was said earlier is we could call this.getConnectedAgent, this.getConnectedAgent of index, and that's going to return to us a reference to the agent for this line. So if it's line 0, get this.getConnectedAgent of 0 of index is going to be this.getConnectedAgent of 0, and that's going to return to me a reference to that particular person, to that particular agent. And if I want to get that agent's X coordinate, how do I do it? I call, okay, now that I have a reference to it, I can call its getX. Ladies and gentlemen, this is a reference to me. I can, because it's a reference, I can put dot and I can call this.getConnectedAgent. That returns a reference. Now that I have that, I can do dot.getX, and that returns a value for the X coordinate for that agent. Now remember, we have to go over, if that agent has XB, and I have location XA, I have to subtract XB minus XA to get DX. So, ladies and gentlemen, what's my location? We saw it earlier. I put it up there and then I got rid of it. What is it? What is my location? Sorry? Okay, but how would I write it? Who's x? This dot get x. Thank you. Okay? That's the answer. That's the answer, ladies and gentlemen. That's as bad as it gets in these Java sort of exercises, okay? And similarly for dy. By the way, this is all going away in AnyLogic 7, but sometimes there's oldies but goodies. So ladies and gentlemen, let me move this over so you could see it in all its glory. Actually, I have it. I think I have it. Here we go. This is, so folks, this is my location. This dot get x, comma, this dot get y. That's my location. This is its location. This dot get connect. If this line is called index, it's either 0, 1, or 2. So I have 3 connected agents. The location of this guy is at this dot get connected agent of index dot get x, and similarly dot get y. Does that make sense, folks? Who needs help? I'm surprised if half the class doesn't need help here. Who needs help here? Kurt stands ready.
I think you're surprised. I think you could do a lot.
Okay, that's wonderful. So the formula for get x, for dx should be this guy here, minus that, and similarly for that. Does that make sense? People?
What will this be like in the next version of it?
Sorry?
What's this going to be like in the next version?
You won't have to put a formula.
We actually have a link object. that
Yeah,
we
there's a link
created,
object that's
and we
explicit.
have an agents, and you can just have a checkbox to visualize the links between the agents.
Right.
And it's probably basically just this code that you never see, but you don't have to worry about it.
Yeah. And one of the reasons for this was feedback from boot camps.
I'm not kidding.
But also, we wanted to be able to represent very easily for health reasons. We made the case to AnyLogic, and they listened and put in the changes that you really want to be able to represent different types of links. So there's like family and then there's friends, right? There's people in your needle sharing network, people in your sexual network, and people in your friendship network.
So we'll be able to define those networks differently?
We'll be able to define them each cleanly instead of just having an agent is in a network. They can be at several networks at the same time, and those can be automatically laid out instead of doing this. Yeah, it'll be nifty. Remember, free attendance for these boot camps. As long as there's capacity, you can attend the boot camps again for free. So next year, AnyLogic 7, be here. This will be easier. Okay, so folks, let's run this now. Okay, so I'd like you to run this model. And this is what you should see, something like this. Do you see that? Who needs help? Who needs help? Okay, help. Wendy? You're right. Okay, who else needs help? Winchell, deploy to front. Who else needs help? No, it's up to stochastics. Sorry? Sure. So again, the way to read this, folks, is I have some reference. It's automatically, I have a reference to myself. And I could say this, so from that reference, that's this. And I could say, hey, get my connected agent at the, for the connection number 0. And then I can get its x value. So that's the x location of that connected agent, that very first connected agent. And I can subtract off my x value. And similarly, I can get its y value and subtract off my y value. What is this thing? I'm just asking myself, hey, what's my y value? What's my x value? Does that make sense? And remember, the key way to read this is, if I call this .getConnected agent, this is a reference, this returns itself a reference to another agent, the neighboring agent, and then I can get its X value, okay? Okay, so who needs help? Help is on its way. Who needs it also? Okay, so folks, do you see something like this? Okay, so so now we have a network. We have people. We have a network that's not only logical. We have a network that's visible. Okay, it's a visible network of connections between agents. And if we go down and we scroll to particular agents, I should have asked you how I do that. Tell me another way to do it besides this menu. How else can I get to see the agents on a one-by-one basis? Good. Click on the population, and I can go through them one by one. It shows to whom they're connected, where they're located, all those sort of things. Okay. You'll notice if I just click once, it'll tell me the names of the population members, how many people are there, and in general, this is sort of a nice thing. So the environment tells you its characteristics. For example, how big it is, how many agents are in it. What the network type is. In this case, it says networks with distance less than 50 are connected. Okay, so ladies and gentlemen,